Hello friends, today we will be doing Math Kangaroo level 5 and 6, year 2023. We will be doing the 5-pointer questions. I already have made 2 videos for the 3-point questions and the 4-point questions. The link is in the description box. Let's just start. Question 21. Tian wants to draw figures in the 6 boxes of the pyramid as shown. Each box should contain all the figures in the 2 boxes directly below it and nothing more. She has drawn the figures in some of the boxes already. Which figure should she draw in the box in the middle of the bottom row? So they're asking what should be drawn here. Now the question says this is a pyramid of 6 boxes, 1 2 3 4 5 6. So basically what it means is if this particular box has all these shapes, so these shapes should come from these 2 boxes. So whatever shape is here should come from this box, whatever shape is here should come from this box, and like for this box it has to come from this and this, and for this box it has to come from this and this. So that is the question. Now let's see. Now there is a circle already here. So the circle will be here. There is a circle and a square here. So circle and square has to be here. So if you see the circle, there is a circle, there is a circle. So these circle and a square is already gone, right? So we need a circle and 2 triangles that has to come. Now let's look at the options. Say if we say option A. So suppose if I put a square and a triangle and a circle, so the square will come here, a triangle and a circle will come here. There's already a square, so another square and a triangle and circle will come here. So what will happen? You'll have 3 squares here, but then you don't have 3 squares, you just have 1 square. So A is not my answer. Similarly, if you try for other options, it will not fit in. The only option that will fit in is D. So let's just try for D. Suppose we have a circle and a triangle. So this one will have 2 circles and a triangle, and this one will also have 2 circles, a triangle and a square. So let's just check. So you have 1, 2, these 2, and these 2 are gone. There is a square and there are 2 triangles, right? So this fits in. So the answer for question 21 is option D. Question number 22. Martha chose one of the 5 structures below. So these are the 5 structures A, B, C, D, E below, and combined it with the structure on the right. So she combined it with the structure. The table shows the number of cubes in each column. So these are the columns. Okay. Like these are the rows. So these are the columns like this. In each column, in the combined structure, when seen from above, which of the 5 structures did Martha choose? Now, if you see here, so this is already 3, correct? So this 3 is already taken care of. So then for this particular column, I need 2 and a 1. Okay, now if you see here, okay, I need a 2 and a 1. So B is not my answer. Similarly, C is not my answer because I need 2 and a 1. This is 1 and a 2. So that's not my answer. Similarly, E is not my answer because it's only 1 and 1. Now, so the options are between, one second. The answer is between option A and D. So it has a 2 and a 1. Similarly, this has a 2 and a 1. Then let's move on. So this gets taken care of. Then in the middle row, you have a 2. So you have a 2 here, and then you have a 1 and a 0, right? So if you see option A, you have 2 here. Okay, whereas we just need a 1 and a 0. Like this is 1 and there's nothing here, right? So option A is not my answer. My answer is option D. Like if you still want to check further, this has to be a 3. Now you don't have a 3, but option D, you have a 3, and then you have a 2, and then you have a 1. So option D will fit in perfectly with this shape. Let's move on. Question 23. Elise has 2 machines. Machine R rotates the paper 90-degree clockwise. This is 90-degree clockwise. And machine S stamps the paper with this symbol, right? In which order are the machines used to create the image below? So if you see this image, it starts like there are 2 things here. You need to see this here and this is here. So basically what it means is it came here, it came here, and it came here. So this has been rotated thrice. Right? And then even the stamp, when you see, whenever you put the stamp, it is erect, and then it'll turn this side, and then it'll turn this side. So this also has to turn. Now let's look at the options. If you see S, so suppose if I put S here, so that means the stamp is first put and this remains here as is, and then you have an R. So what will happen? It will be like this, and this symbol will come here. Then again, if there is an R, then this will become like this, and this will get here. And again, there is an R, so the symbol will become like this. But then that's not the case that I have here. So A is not my answer. Similarly, let's try for a B. Then suppose it's R. So R means this symbol will come here. Then you have an S. So you have this thing here. And then again you have an R. So this will turn like this, and this will also come here. And then again you have an R. So it will be turning like this, and then this will come here. So it will fit in. So my answer for question 23 is option B. Question 24. Four stakes are placed along a 120-meter track. Four stakes means 1, 2, 3, and 4. They are placed along this 120-meter track. 120 meter, if you add them up, like 24 plus 30 plus 64, you'll get a 120-meter track. What is the smallest number of stakes that should be added so that the track is divided into sections of equal length? Okay, now if you see here, what is the smallest number? So we need to find the GCF or the HCF. So what is the GCF of these? Let's do with a 2. So you get a 12, 15, 33. Then you do it with a 3. You get a 4, 5, and an 11. So now there's no common factor. So the highest common factor, the greatest common factor is 2 times 3, which is a 6. So basically the smallest number of sticks that should be added. So you have a 120-meter track, which should be divided into 6 equal sections. So there should be 20 sticks. Now out of 20, we see how many have already been put. It's already been divided into 1, 2, and 3 lengths. So I will subtract 3. So it needs to be further. So what is the smallest number of stakes that should be further added? 17 stakes should be further added so that the track is divided into equal sections. So my answer is 17. Sorry, actually it should be divided into 20 equal lengths, and out of them 3 lengths have already been divided. So I need to put in 17 more so that track is divided into equal lengths of 6 each. Question 25. On a table, there is a tower made of blocks numbered 1 to 20. So these are the tower made from 1 to 20. Emma builds a new tower in the following way. She takes 2 blocks from the top of the original tower and puts them on the table as the base of the new tower. She continues by taking the top 2 blocks from the remainder of the original tower and putting them on the top of the new tower as seen in the diagram. Which of the following pairs of numbers are on the adjacent blocks, means next to each other in the new tower? So basically this was the original tower. The new tower will go like this. Let's just start here. So the blocks would be 50 and 49. Then you have 48 and 47. And then if we continue like this, so then you'll have 46 and a 45. So basically the larger number comes first and then the smaller number. So we'll keep doing it. So again, you'll have a 44 and a 43. And then you have a 42 and a 41. So we'll just keep doing it like this. So basically this is how the blocks would be on top of each other. Now I didn't have place. So basically this will come here on top of it, and that's how the tower would be built. Now, which of the following pairs of numbers are on the adjacent blocks of the new tower? So 29 and 28. So if you see 29 and 28, they are not together. So this is not my answer. Similarly, 34 and 35. So 34 is here. So basically it is like this. So you have a 34 and a 33. and this one is 36 and 35. So they are not together, correct? So this is not together. Similarly, 29 and 26. So if you build it here, so then this is 26 and 25. So again, 29 and 26 will not be together. 31 and 33 are also not together. So the only answer that will fit in is 27 and a 30. So if you see here, you have a 27 and 30 next to each other. So my answer for 25 will be option E. Question number 26. Martin has three cards with numbers written on both sides. The card number with one on one side has number 4 on the opposite side. The card with 2 on has 5 on the opposite side, and the card 3 on has 6 on the opposite side. Martin randomly places 3 cards on the table and adds up the 3 numbers he sees. How many different sums can Martin get? So basically what he says is you have to try different combinations with these numbers. So if he's using 1, he cannot use a 4. So let's first start what combinations are possible. So I do 1, 2, and 3. So I get a 6. Similarly, if I keep one constant, okay, and instead of 2, I can take a 5 and a 6. So I'll get a 12. Similarly, I can take a 2 here, and then instead of 3, I can take a 6. So I get 9 here. So these are the 3 numbers. Now let's just try with the 2. So suppose it can do, so we've already done 1, 2, 3. So you need not do 2, 1, and 3 because we'll get the same total. So what can I do? I cannot use a 5 with 2. So it will be 2 plus 4 plus 3. So this is 5 plus 4, which is a 9. Or I can do 2 plus 4 plus 6, which is a 12. Or I have done 2 plus 3 plus 4 is done 2 plus 1 plus 6, which is again a 9. So these are the numbers. So if you see now, what are the common sums that I'm getting? I'm getting a 6, I'm getting a 9, I'm getting a 12. Okay, so it's 3, but we have to keep trying. Now let's just try with the 3. So we need not do 3 plus 2 plus 1 because it's already done 1 plus 2 plus 3. So what I can do, 3 plus 2 plus 4, which is again a 9, or I can do a 3 plus 5 plus a 6. So which will become, a, no, you cannot do a 6 because 3, so you can do a 3 plus 5 and a 4, which will become again 3 plus, so this will become a 12. So is there any other combination that you feel will be there? We can also take this combination, which is 4 plus 5 plus 6, which is a 15. Okay, so this is also one of the sums that I can get if I only take these. So how many different sums are possible? So there are 4 different sums which are possible. So the answer for 26 is option B. Question 27. In a second-hand shop, 2 hats are sold for the same price as 5 skirts. Three skirts are 3 skirts for the same price as 8 t-shirts and 2 t-shirts for the same price as 3 caps. Which of the following collections is the most valuable? Whenever we are doing these questions, it's better to allot numbers so that it becomes easier to calculate, and the relationships is quite clear. So let's just start with, so they're saying one hat, uh, they're saying 2 hats are sold for the same price as the 5 skirts. So what are they saying? 2 hats are equal to the price of 5 skirts. So the number should be, such a way that, it should be a multiple of 2 as well as 5. So let's just say one of the hat is 10. So this becomes a 10 and 10, and this is 20. So 20 divided by 5 is a 4. So basically, what we have established is that the hat is say 10 and the skirt is a 4. Okay, then we go to the next relationship, which is 3 skirts, which is this, is the same price for 8 t-shirts. So this 3 is equal to 4 times 3 is 12, and you have 8. So 12 divided by 8 will be 1.5. So each t-shirt is 1.5. Let's just write T. So each t-shirt is 1.5 and the skirt we have already said it to be a 4. Then two t-shirts for the same price of 3 caps. So this is 1.5 times 1.5. So this is 3. And so that means each cap is for 1. Right? So this is the value. We have actually just, these are hypothetical numbers, like you start with this and then come up with these numbers. So now let's just check the options as to which one is the most valuable. So we found that one hat is 10 and 5 skirts is 20. So this is the total value of this combination, which is 30. Then you have a hat, 3 skirts, which is 12, and a cap. So this combination will be 23. 8 skirts, so 8 into 4 is 32, plus 6 t-shirts, so 6 into 1.5 is a 9. So you get 32 plus 9, which is a 41. 37 caps, so 37 into 1 is a 37. 3 skirts, which is again a 12, plus 3 caps is a 3, is 15. So now if you see what is the most valuable that I have, which is the biggest number, it is 41. So my answer for 27 is option 3, 8 skirts and 6 t-shirts. Question 28. Sonia and Robert are playing a game. They can alternately take 1, 2, 3, 4, or 5 tiles from a pile of tiles. Whosoever takes the last tile or tiles loses. At one point of game, there were only 10 tiles left in the pile, and it's Sonia's turn to take some tiles. How many tiles should Sonia leave to Robert to be sure that she will win? So basically, you have 10 tiles. 6, 7, 8, 9, and 10. So now it is Sonia's turn to pick. And so she should be sure that, how many tiles should Sonia leave to Robert to be sure that she will win. So let's just start with, say, option A. So suppose she takes this tile. Okay, so that means there are 9 tiles for Robert to pick. So what can Robert do? So say Robert picks 5s, 1, 2, 3, 4, and 5. So this is what Robert picks. Then it is Sonia's turn again. Okay. And so if suppose Sonia picks 2, then what can Robert do? Robert can just only pick 1. Correct. So then Sonia has to pick this and then Sonia would lose. Right. So A cannot be my answer. They're saying she should be absolutely sure. So let's just try again. So suppose Sonia leaves 8 tiles for Robert. So this is what Sonia picked. Okay, so then what can Robert do? Suppose again Robert would pick the maximum. Okay, so suppose if Robert picks maximum, so he picked these tiles. Then what would Sonia do? So again, if say Sonia picks this one, then Robert would pick this one, and then again Sonia has to pick this one. So Sonia would lose again. Okay. Uh, now let's just try. If Sonia leaves, so Sonia picks these 3, so she leaves 7 tiles for Robert. So now how many, what is the maximum that Robert can pick? He can pick 5 or he can pick 4. So let's just say he picks 4. So 1, 2, 3, 4. So this is what Robert picks. Okay, then suppose how much now with Sonia's turn, then Sonia will pick 2. Correct. So how much? So Robert will have to pick the last one and the Robert will lose. You can try it with different combinations. Like for example, let's just try. So again, suppose Sonia picks so many. Okay. And suppose Robert takes 2. Then again, it is Sonia's turn to pick. Okay. So Sonia would. So now if Sonia has to pick, so she'll pick 4. So then Robert has to pick this. So in this case, Sonia would have an upper hand. And so how many tiles should Sonia leave to Robert? She should leave 7 tiles to Robert so as to be absolutely sure that she will win. So my answer for question 28 is option C. Question number 29. Which of the following four shapes has the greatest area? Now, whenever you have these questions, just join these and give any numbers to the sides. Let's just say the numbers are 10. Okay, each side is 10. So now which of the following shapes has the greatest area? So what is the area of the shaded figure here? So how do I find this? What is the total area here? 10 times 10, which is 100, minus this triangle. So suppose this is 5 and this is 5. So area of a triangle is half times base into height, correct? So the base here becomes 5 and the height also becomes 5, 5 and 5. So this becomes half into 5 into 5. But then since you have two of these, so you can cancel this. So you get a 25 here, and this becomes the base and this becomes the height. So this will be half into 10 into 5. So this again becomes 25. So the area of this is say 50 square units. Okay, now let's just do a similar thing here. Correct? So this becomes 5, 5, 5, 5, 5, 5, because each one of them is 10. So the total area of the square remains 100. So in this case, what will be the area of this square? It will be again half times base times height. And since I have 4 of such triangles, I do 2, so it's 25 times 2, which is 50. So the area of this is also 50 square units. The area of this is also 50 square units. Now I do the same thing. So this becomes a 5, 5. This is a 10. This is a 10. This is a 10. Now, if you see this, the height here is less than 10. So probably let's say 8, right? So what will be the area of these two triangles? This is base into height. And there are two such kind of triangles, right? This is the base of 5 and height. So I cancel this. So 5 into 8 is a 40. So if I do 100 minus 40, I get 60, right? And then I do the similar thing again. So this becomes a 5, 5, 5, 5. So if you see here again, I have 4 of these triangles. And so let's just do this. So this will be base into height. And there are 4 such kind of triangles. So the total area will be 50. So 100 minus 50 will be a 50. So which one has the greatest area? 60. So the answer will be the crown. Let's move on. Last question, question 30. An explorer wants to find a path through the maze shown from the point marked starting to the finish point. She can only move horizontally or vertically. So you can move horizontally or vertically, you can't move diagonally. And she can only pass through white circles. She also has to pass through all the white circles exactly once. When she reaches the circle marked X, what will be her next move? So let's just start. So how do we go? So I'll go like this. Then you go like this, then you go like this, then you go like this. I need to cover as many, I need to cover all the white squares. So that's why circles, I'll go like this, then 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 I'll go like this, like this. Correct? So I have crossed all the white circles. And so when she reaches a circle, what will be her next move? So this is X. So you're going down. So my answer will be option B. Right? Okay. I hope you like this video. Do subscribe to my channel. Leave a comment if you want me to solve any year paper or any specific question. Thank you for watching.